In this video we are going to watch at the results of the circuit like this over here. So I have a gate driver that is controlling a coil, and then the negative output of that coil is connected to a choke. In this case it is used as a one-to-one transformer, rectified, and then to a light bulb. I have two coils that are separate, and that is what you can see over here. So these are these two coils, or this one's over here. Then the center coil is the one that I'm controlling with the MOSFET. Then we have the negative spike going to two diodes, going to the choke over here, rectified, and to the light bulb, coming back to the positive of the power supply. The current I'm also measuring over here, and that's the blue trace on the scope. The yellow trace is the voltage that I have over here on the negative spike, so it's around 200 volts at the moment. Then over here I have the purple and the light blue trace, are the two voltages over here. As you can see, they are approximately the same. Peak value over there is around 430 volts for the purple one over there. So what I want to show you in this video is the importance of using that negative. As you can see over here, at this point in time I'm using around, for easy say, 20 milliamps, and I have that voltage output on my two coils. Also something very interesting, when I take two diodes, and I will bring it closer so you can see it. So I have three coils in series and two LEDs in anti-parallel. If I go to this side, then we can see that the red turns on, the red LED. If I go to the other side, you can see that the blue LED goes on. So we also see a change in polarity. Now one can say there is a difference in voltage between the two LEDs, but originally I did a test with two of the same bright LEDs like this one. So they are from the same voltage, and I also had that same thing that I was seeing. So what is going to happen now? I'm going to bridge the diodes. As you can see, we are still switching, but I'm drawing 600 milliamps. And in this case, my power supply is limiting it to 600 milliamps. Now, when I come close to see what's happening with the magnetic, you see the LEDs don't go on anymore. Also on this side, the LEDs don't go on. So normally we draw now 600 milliamps instead of 20 milliamps. So the magnetic field should be much bigger, according to what we normally see. But that is not the case, because when I take it away, I will put it there so you can see it. The moment I take away bridge, you see the red LED goes on again, and we have back that high spike also on the two coils over here, but we are only drawing 20 milliamps. So that is the importance of using the negative spike. And what happens when I make that bridge is that I make the connection from here to there. So just like in normal, where you place a diode across the coil to kill the negative spike. So this is the advantage of using this kind of circuit. Not only you can use the spike in a good way, but also you are limiting the current input, and you have more magnetic output. So one can ask, why do we still place a diode across a coil?